So in the previous example, we have looked at a chemical reaction where your limestone was converted to lime, but there all of the limestone were converted to lime. But in most of the chemical reactions, most of the time, your reaction is not 100%. And sometimes if you have more than one reactant, there will be one reactant which is excess or limiting. So in order for us to do a mass balance on those kind of system, we have to understand these 5 important terminology and concepts first. The first one that we'll be looking at is limiting reactant and excess reactant. The second one is that extent of reaction. The third one is the conversion. The fourth one is selectivity, and the fifth one will be yield. So all these terminology are important for us to understand, so that we will be able to solve for our material balance for reactive system. So let's look at the first thing. So limiting reactant, as its name says, is the species in the chemical reaction that would theoretically round out first. Meaning that if you have two types of reactant, one will finish out first. If one reactant is finished, then the reaction we can say is the complete reaction. And if you have a limiting reactant, then definitely you have a excess reactant. So excess reactant is the opposite of limiting reactant, a species that is not limiting reactant. Okay, so for example, let's say you have the hydrogenation of acetylene to form ethane. So you have this chemical equation. This is your acetylene, C2H2 plus, this should be 2H2, and then you will form C2H6. So this is supposed to be capital 2, not subscript. So 2H2. So first of all, again, if we are using with chemical equations, we have to see whether it's balanced or not. So I have 2C here, 2C here, 2 plus 4, 6H, and this is 6H. So this is a balanced equation. Now suppose that 20 kilomole per hour of acetylene and 50 kilomole of hydrogen are fed to a reactor. Which one is the limiting and which one is the excess reactant? So usually we have to decide which one is our limiting reactant, which one is our excess reactant, because once we know what is the limiting reactant, most of the time the conversion will be based on the limiting reactant, the yield will be based on the limiting reactant, the extent of reaction will also be based on limiting reactant. So determining which one is our limiting reactant is one of the important part of a chemical equation, chemical reaction. So let's say we have, so I write again the equation, C2H2 plus 2H2 will get C2H6. And then if you were to just draw a flow chart, so we have here C2H2, right? And this is 20 kilomole per hour. And then I add in with H2, which is 50 kilomole per hour. So now we want to decide which one is the limiting reactant and which one is the excess reactant. Which out of these two will control how much C2H6 we produce. So if we look at this stoichiometric reaction, this is a balanced reaction. So 1 mole of C2H2 will react with 2 mole of hydrogen and will produce 1 mole of C2H6. So just by looking at this stoichiometric coefficient, if let's say I have 20 kilomole of C2H2, I know that I will need to have 40 kilomole of hydrogen to produce 20 kilomole of C2H6. Now this is saying that this is a complete reaction, meaning that whatever reactant I put, I will get the product. So if you look at here, based on this stoichiometric coefficient and stoichiometric ratio of mole balance, we can see here that if I have 20 kilomole, I will only need 40 kilomole in order to complete the reaction. But here I have 50 kilomole, meaning that this is my excess reactant. Okay, this is my excess reactant, and this one is my limiting reactant. Why? Because this is the reactant that will control how much product that I will get. So if let's say I have 10 kilomole here, then I will need 20 kilomole in order for me to get 10 kilomole. Okay, so let's say, so in this case, this is my limiting reactant, this is my excess reactant. So let's say if I change this one, okay, let's say I put here, just remove everything from here. So let's say if I put here, I have 100, and then here I have 20 kilomole. Okay, so I have changed the number here. So now, again, if you look at our stoichiometric ratio and stoichiometric coefficient, 1 mole of C2H2 will react with 2 mole of hydrogen to produce 1 mole of C2H6. So if let's say I have here 100 kilomole per hour, I will need 200 kilomole per hour of H2 in order for me to get 100 kilomole per hour of C2H6. Now, if I look at my flow chart here, I have 100 kilomole, but for hydrogen, I only have 20 kilomole. So if I compare this 20 kilomole with the 200 kilomole that I need, I say that it is not enough. So meaning that in this situation, this is my limiting reactant, and this is my excess. Okay, so you have to compare whatever you have with the whatever maximum amount is needed based on your stoichiometric reaction. Okay, so that is how you find out what is your limiting reactant. The second important thing that you need to know is that extent of reaction. So extent of reaction is also another method for you to decide your limiting reactant. So extent of reaction, okay, so this is the symbol for extent of reaction. It describes how much reaction has occurred. And this can be calculated using the following formula. So this is a very, very important formula you need to understand. Okay, so extent of reaction again is to show how much reaction has occurred. So you want to see the degree of completion. So let's say this is your extent of reaction. Your Ni is the mole of final mole of a species, NiO is the initial mole of the species, and Vi is your stoichiometric coefficient. And again, this one is your extent of reaction. And the unit here is the same unit as your mole. So let's say if your Ni is in gram mole, so your extent of reaction will have a unit of gram mole. Or if your mole, the N here is in the unit of pound mole, so you have a unit of pound mole for your extent of reaction. If your mole here has a unit of kilomole, kg mole, so your extent of reaction will have a unit of kg mole. So depending on this one. If you look at here, if you are still confused and you are not sure which unit you want to use, So if you look at here, this thing will have a unit of mole, either gram mole, pound mole, or kilomole. So let's say this is a unit of mole. Okay, this is a unit of mole. And then this one will also have a unit of mole. Okay, this one is dimensionless, meaning that it does not have any unit. So if you look at here, mole minus mole, so definitely this thing will have a unit of mole. So it will follow whatever unit your Ni and NiO will have. Okay, and then again here, the reaction with the smallest maximum extent of reaction is the limiting reactant. Okay, the extent of reaction for the process or reaction. So if let's say you don't want you to use your stoichiometric coefficient and stoichiometric ratio to decide which one is your limiting reactant, you can always use this extent of reaction to determine your limiting reactant, meaning that the reactant with the smallest maximum extent of reaction, meaning that here you have 100% completion. So when you have done 100% completion and you find whichever reactant has the smallest value of extent of reaction, that is your limiting reactant. So let us look at this example so that you can understand more about how to use extent of reaction to find your limiting reactant. So let's say you have this equation, A plus B plus C will give you some products. So we are not concerned about this product side. We are only concerned about this side because we want to find which one out of A, B, and C is our limiting reactant. And the question gives us if there are 1.2 mole of A, 2.7 mole of B, and 1.3 mole of C. So which one is the limiting reactant? So if you were to use the extent of reaction equation, so this is the symbol, is equal to Ni minus NiO over Vi. So again, Ni is your final composition of mole, NO is the initial composition of mole, and Vi is your stoichiometric ratio. So for stoichiometric ratio, if you are dealing with the reactant side, it's going to be a negative value. If you are dealing with the product side, it's going to be a positive value. So let us say we want to find extent of reaction of A. Okay, so if let's say we are talking about the maximum value of A we can use, meaning that initially we had 1.2 mole, maximum here meaning that all of A is used. So your final mole will be 0. 0 minus 1.2. 1.2 is my starting value, divided by the stoichiometric coefficient for A is 1, so it's going to be negative 1. So I will get an answer of 1.2 mole. That is for A. This right here. So I do the same thing for B. So extent for reaction of B is equal to, again, the maximum B I can use is all of B. So finally I'll have no B, so 0 minus 2.7 over the coefficient here is 1, so negative 1. So I'll get a value of 2.7 mole. And then if I use for, this one is for B, and then extent of reaction for C, again no C at the end, minus at the beginning I have 1.3 mole divided by negative 1, so I'll get a value of 1.3 mole. So if you look at here, the smallest maximum value, so among A, B, and C, this is the smallest if I use the maximum amount of A. Maximum amount meaning that I have used all the value of A. So I get the value of 1.2. So meaning that for this reaction, the extent of reaction is equal to 1.2 mole. Because why? Extent of reaction is based on my limiting reactant. And remember, this is important. One chemical equation, one chemical reaction will only have one extent of reaction. Okay, we are only using extent of reaction this way because we want to find which one is our limiting reactant and which one is our process extent of reaction. So this is the meaning of this final sentence. The reactant with the smallest maximum extent of reaction is the limiting reactant, and that is the extent of reaction for the process.